Hello, my name's Amani, and I have an unfortunate case of chronic enthusiasm. Give me a 5-minute task, and suddenly there's a color-coded plan, a playlist, and a scheduled Oreo break. So naturally, I fell in love with the one hobby that's basically organized chaos with explosives rockets. How I got here, you may ask? Well, come join me through the research, build, and flight of my National Association of Rocketry certified Level 2 high powered rocket. As I answer the question, describe a time you fully immerse yourself in something and what inspired you. When I first got to college at the very spirited University of Georgia, I didn't really know where I wanted my mechanical engineering degree to take me. So naturally, I tried everything. CubeSat? Sure. Motorsports team? Why not? Robotics? Add it to the list. And then lastly, there was the American Institute of Aeronautics and Astronautics. Funny enough, I actually walked past their table at the club fair telling a friend, not AE, probably don't need to join that. Until the president called me out and practically dragged me to the first general body meeting. But anyways, it was here where I built my very first rocket. Well, my first actual rocket, not including me and Parsa's mini Nicki Minaj abomination. My level 1 high-powered rocket wasn't anything groundbreaking. A 3D printed nose cone, some laser cut fins, a cardboard tube, a motor, slather on some epoxy, and you're basically done. Honestly, at the time, it was just for fun, until I drove out to South Carolina, loaded that motor, and actually watched it launch. There, something clicked. The sound, the smoke, the sky, it all felt alive. After that, I begged the seniors to let me join the intercollegiate rocket engineering competition. And after giving a very convincing lecture about gyroscopes, they said yes, and suddenly I was the team's first freshman member. Now, this was no cardboard and wooden fins. This rocket was far bigger than my level 1. With custom avionics, a payload bay, a fiberglass body, and a dual deployment recovery system, I didn't even know what an avionics bay was at this point. Yeah, I was now responsible for its housing. So I researched, I experimented, I failed terribly. I fall into rabbit holes of flight and guidance until it somehow started to finally click. After about what felt like millions of iterations and even more failed 3D prints, the custom avionics load was ready. On it sat two altimeters, a GPS, three switches, and three 9-volt batteries. Honestly, I couldn't sleep the night before launch. If it failed, our 10,000-foot target would vanish. At the familiar launch site of my level 1, I set up electronics and double checked every connection on the system, until we eventually got to the pad. I remember looking at the rocket sitting there, stomach in knots. When I finally ignited, I held my breath until the moment the parachutes deployed. Flawless execution. 10,523 feet, read the altimeter, approximately within 5% of our target range. That same rush I craved hit me all over again. Leaving UGA was bittersweet. I was proud of the work, the friends, and what I'd learned, but there was still more to do. Enter Georgia Tech. New school, new resources, and a whole new world. I joined Yellow Jacket Space Program, a club dedicated to flying a liquid fuel rocket to the Kármán line, the official edge of space. Liquid rocketry was everything my earlier projects weren't. Hotter, faster, and terrifyingly complex. Combustion chambers, liquid oxygen, leak-proof seals, it felt like a new language. So on the engine development team, I got hands-on. I sat behind grad students arguing about design choices, secretly Googling the words they use, then dove into manufacturing, machining any part I could. I even took a stab at test procedures. I asked the stupid questions, read the textbooks that looked like hieroglyphics, and spent more nights than I can count hunched over CAD models and half-finished calculations. But slowly, curiosity turned into confidence. Soon, I became the chief engineer for the full-scale turbopump production and sub-scale pump testing. Full scale felt different, bigger, heavier, and now far more personal. So I dedicated myself to mastering the system, optimizing the impeller, creating a CAD to ensure proper assembly, learning the necessary FEA and CFD, and researching every bearing, seal, and O-ring in the design. Every bolt torqued, every dataset logged, it was all part of the same obsession. Build it, break it, fix it, make it better. Somewhere between the late night design reviews and 2 a.m. CAD changes, I realized the challenge wasn't just building a pump, it was leading a team. Teaching new members, keeping steady when everything went sideways, and making sure every person knew why their piece mattered became the real work. And in the end, the pump became more than just hardware. It was the embodiment of my approach audacious in ambition, meticulous in execution, and relentless in iteration. Now, as a junior, I look back at every late night, every failed test, every spark of excitement, and I see the thread connecting them all the curiosity, the chaos, the chronic enthusiasm. Now I arrive in Alabama to fly my level 2 rocket, the one I'd promised my UGA friends I'd finish, the one that carried a little piece of who I used to be, the one built by a far more experienced version of me. This rocket, and everything that came before it, isn't just a project. It's the full circle moment that reminds me of why I ever looked up at the sky in the first place.